Hello, Honors Algebra. Mr. Lawrence here with your flip lesson for February 1st. That's a Wednesday. And we're going to start off by doing two quick exponential graphs. I'll generate their t-tables. Hopefully you know them well enough by now you can do them along with me. All right, and your parents can see you cry because you know I love to make you cry and you know how difficult these are. All right, so I'll tell you what, I'm going to go with 2 and 1 and 0 and -1, -2, and that ought to be enough for me to get the idea of my graph. Okay, so if I do 4 to the second power, I'm going to get 16. 16 minus 6 is 10, so 210 is on my graph. So 210 is on my graph right there. I put 1 in, I'm going to get 4 to the first power, which is 4 minus 6, which is -2. So I'm going to get 1, -2 right there. When I put 4 to the 0 power, I'm going to get 1. 1 minus 6 is going to be -5. So we're going to get 0, 1, 2, 3, 4, 5. Right there is on my graph. All right, when I put -1 in, that's going to cause that 4 to become a 1/4. So I'm going to have 1/4 minus 6. Well, 6 minus a 1/4 would be 5 3/4. 5 3/4. But since the 6 is larger than the 1/4, my answer is going to be a -5 3/4. All right, so I'm going to go down to -5 3/4. There we go. All right. Okay, so if you have any background noise, don't mind that. That's just Mr. Steve taking care of his business. All right, so we've got 4 to the -2nd power. Well, let's see, 4 to the 2nd power is 16. So 4 to the -2nd power must be 1/16, right? And then I'm subtracting 6 from that. Well, 6 minus 1/16 would be the same as 5 and 15/16, and that'd be negative. In other words, it's going to be 5 and a fraction that's pretty darn close to a whole. So it's going to be really close to -6. So I'm going to get -5 and 15/16, and that would be right about there. Okay, now you can probably tell that my fractions are getting closer and closer to -6. And my asymptote is going to be at -6. Let me slide that down just a smidgen. There we go. My asymptote in this case is going to be y equals -6. That'll be the line that the curve is approaching but never actually touching. So to draw it, it's going to do something like this. And again, you don't have to be perfect on it. It is very difficult to be perfect on there. Very difficult. Do the best you can. Make me know that it's going up and approaching the approaching the asymptote, and you'll be good. All right, let's try one more. You can try this one on your own. Go ahead and pause. When you're done pausing, I'll assume you want to see the solution because I'm going to go ahead and solve it. I'm going to make my t-table. I'm assuming you're ready to see a solution. And, oh, with that 1/5 there, I'm not going to go very big. I'll tell you what, I'm going to go 1, 0, and I'm going to go -1. You know, 2 might actually, yeah, -2 will be okay. 2 won't work so well. All right, so, you know, it looks kind of strange, so out of insecurity, I'm going to do the ones I know first. I know that if I put 1/5 to the 0 power, I'm going to get 1. 1 plus 2 is 3. All right, so I'm going to get 1, 2, 3. Okay, if I put 1 in there, I'm going to get 1/5 to the -1st. Well, that's the same as 5, and 5 plus 2 is 7. All right, so 1 is going to be up at 7, 9, 8, 7 right there. Okay, if I put a -1 in there, the negatives will cancel, so I'm going to get 1/5 to the +1 because I have a negative and then a -1, right? So I'm going to get 2 and 1/5. All right, so that'll be -1 will be at 2 and 1/5. All right, if I put a -2 in there, the negatives will cancel. I'll get 1/25. I'll get 2 plus 1/25, which is 2 and 1/25, which is getting pretty darn close to 2. So again, you should be able to tell your asymptote in this case. In this case, the asymptote is going to be the line y equals 2. That's my asymptote. Remember, that doesn't have to be in the graph, but you have to be able to identify it. Y equals 2 is my asymptote. And no, I did just not call you a naughty word. It's an asymptote. Get your minds out of the gutter, please. All right. And so again, the graph will do something like this. It'll come on up. And notice I'm not going to cross the line where x equals 2. That would be this vertical line here, right? X equals 2 going up that way. Because when x is 2, I'm going to get 1/5 to the negative second. 1/5 to the second would be 1/25. 1/5 to the negative 22nd will be 25, and 25 plus 2 is 27. So it's not going to cross the graph until I go way, 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 way up there. Okay. That's enough of that. Now we are going to talk about something that is really cool, and we're going to have an application in class. I'm going to do a lot of lecturing tomorrow, but I think you're going to find it very, very interesting. And it's about half-life. I don't know if you've ever heard of half-life. It refers to the amount of time it takes half a substance to decay. All right, now think about that. Your body is made up of different substances, right? One of the things that is in your body, and is in all organic things, is carbon-14. Okay? It's a type of carbon. And scientists many years ago discovered the half-life of carbon. In other words, they discovered that if you had 100 grams of carbon, that in 5,000, I'm sorry, that's today. So that would be like in 0 years, you have 100 grams. In 5,700 years, you would only have 50 grams of carbon-14. And then in 11,400 years, you would only have 25 grams of carbon left because it starts to decay. It doesn't really evaporate or disintegrate. It decays and dies away. Okay? This table up here shows you the half-life of carbon-14. They can use this. It's not perfect, but they can use it to guesstimate how old something is. For example, if they find that a substance has, hold on one second, 1/2 of its carbon-14 left, they know it's 5,700 years old. And you notice in this middle column here, oops, I didn't mean to move that like that. They notice in this middle column here that in each of these, the power to the half is raising. Okay, so 1/2 to the second power is the same as 1/4, or 25%. If the substance has 25% of its carbon-14 remaining, or 1/4 of it, then the object, whatever it might be, is 11,400 years old. Well, how might you use this? Well, I don't know if you ever heard of the Dead Sea Scrolls, but the Dead Sea Scrolls were some scrolls that were found in the area of the Dead Sea, which is in Israel. And they were the writings of many of the books of the Old Testament. They were found on accident. They were stuck in a cave. I think it was a kid found them. He was playing and went in the cave, and he found these old pottery jars, and he found these old writings, ancient writings, and he turned them over to, I don't know who he turned them into, but they carbon dated them. And they found out that they were actually quite old. See, anybody could write something and claim it's from like 1,000 years ago or 5,000 years ago. Anybody could claim that. But scientists could test the carbon-14 to find out if they're lying or not. Like, think about it this way. Let's say I produced a copy of the original Declaration of Independence. You know, some of you are going to go to Washington, D.C. soon and see an original copy of it. Let's say I found another one, and I decided I wanted to sell it on eBay. It would be worth lots and lots of money, especially if I found one that hadn't faded. it had been protected somehow, and it was totally legible, and you could read everything on it, and the paper was in great quality. Well, you before you bought this from me on eBay, you'd want to make sure that it was real, that you weren't just buying something I'd written by hand. I had just traced the, you know, Thomas Jefferson's writing so well that could imitate it perfectly. Well, scientists could carbon date the paper or the ink in the paper and see how much carbon-14 is left there. And they could determine if it was a fake or not by the amount of carbon-14. Now, it would be a little bit tough with the Declaration of Independence because it's only, you know, a couple hundred years old. And you notice the time span here is 5,700 years. But think about this way. Think about, I claim to have found, no, Hammurabi probably wrote in cuneiform on clay tablets, but let's say I found evidence that Hammurabi, the great lawgiver of Babylon, wrote a book on paper. We don't think the Babylonians wrote on paper. We think they used cuneiform and clay. And if I could prove to you that this book was from the right time period as when Hammurabi lived, it would be an incredible discovery. I'd make millions of dollars, and it would change the way we view history. So the scientists would carbon date it. All right? Here's how this works. See these percentages here in blue? Let's estimate the age of the following. Okay, let's pretend we found a substance and it had 40% of its carbon. Sorry if I'm repeating myself. I was just saying that we had to estimate the age of the following, and the first one, it has 40% of its carbon-14 remaining. Okay, well, I'm going to look up here at my percentages. I know that 50% and 25%. Okay, so I'm going to try to figure out where 50% fits in between, excuse me, where 40% fits in between 50% and 25%. Well, no, what number is halfway in between there? Well, I think it'd be about 37.5%, right? Okay, so if at 50% carbon-14 remaining, the object is 5,700 years old. Where am I getting that from? The table. Right here, 50%. Okay, there's the age up there. Okay, and at 25%, the item is 11,400 years old. 11,400 years old. Okay, well, what number is halfway between 5,700 and 11,400? Well, sometimes that's not so easy to see and just give an answer to. Well, all you have to do is add them together. Okay, and then divide by 2. Just average the 2 and you'll end up right in the middle. All right, so if I average the 2, let's see here. Let me do some long division. Okay, 2 is going to go 8. We're going to get 16, right? We're going to get 5, and that's going to be a 10. Okay, and so finishing my long division here. Oops, I'm out of right mode again. I'm going to get, like, am I doing this right? I'm feeling like I'm making a mistake. Okay, no, that looks pretty good. All right. So I'm going to get 8,550 years old. So if there was 37.5%, the item is going to be 8,550 years old. Now I know 40% is going to fall in between there, but not in the middle. 40% is going to fall here. So maybe a good estimate might be, say, around 7,000 years old. You see how I'm picking up the 7,000? I don't have to be exact. I'm just kind of ballparking it. I know 40% might be right about there. Okay, if I wanted to, I could narrow it down even further, but I think 40% carbon-14 remaining, 7,000 years is a pretty decent estimate. All right, so if I claimed to have found this book written by Hammurabi, and this, you know, he lived a long time ago, and you carbon tested it and found that only 40% of the carbon was remaining, carbon-14 that is, and you the book I would be talking about would be 7,000 years old. Now, off the top of my head, I don't know if that matches up with when Hammurabi ruled, but you would know that I didn't just produce it myself. And even if it wasn't from Hammurabi, it would be a very valuable argument. Okay, let's try another one. Hold on one second. Let me get the board all set. Okay, this time let's estimate the age of something that, say, has 67%, excuse me, of its carbon-14 remaining. Okay, well, okay, I know that 67% is between 100 and 50. So I'm going to have 100% over here. I'm going to have 50% over here. Okay. 67% is going to be somewhere in the middle. Let's see, in the middle here, I think would be 75%, right? 67 is going to fall in here. By the way, at this point, there's, oh, I'm sorry, I'm losing my train of thought. Let me find what number's in the middle here. Let's see here. I got 75 and 50 would be 125. And half of 25, I think, will be mental blank 62.5. Yeah, right? That should be right. 62.5. So I'm going to be looking for something 67%. That is going to be pretty darn close here. 67% would be right about here. Well, let me do this and say, okay, at 50%, I'm at 5,700 years old. Okay, here I'm at 0 years old. That's right. Okay, and then halfway between there, what's half of 5,700? Well, let's see, what's half of 57? Well, half of 56 would be 28, so this would be 2,850 years old. All I did was add 0, 5,700, and take half of it, and now I have half. Now I can add these two together, the 5,700 and 2,850, add them together, and then I'll divide by 2. So 8,550 divided by 2 is going to be 4. Okay, it's going to be 2. 15 is going to be 7, and then I believe a 5. So that means right here is going to be 4,275 years old. I don't know why I added an extra 0 there. All right, so the object in question has to be between 2,850 years old and 4,275 years old, and it's going to be closer to this one because 67 is only 4.5% away from 62, but it's 8% away from 75. So it's actually about a third of the way. So let me see here. I can make even a closer estimate here. 4275 minus 2850. I'm finding out how long the range is. Okay. Okay, and then a third of that, because it's approximately a third of the way. It's not going to be exact, but approximately a third. Okay, 4, 3 subtract 12, 4, and then 5 is going to 1. So a decent estimate would be 1,141 years old. Okay, so this is very useful. Now tomorrow in class we're going to talk about something that many scientists who have carbon dated the item, it will tell you is a complete hoax, but other people who are more religious in nature believe it's real, and they believe that the carbon-14 data was goofed, that they didn't do a very good job. And that's something that's called the Shroud of Turin. And we'll talk about that in class a little bit tomorrow. All right, Mr. Lawrence signing off. Good night, everybody.